Welcome to this introduction to web development. In this session, we're going to explore two of the most fundamental building blocks of any web page you've ever visited, HTML and CSS. We'll understand what each one does, why they work together, and how to start thinking about building a web page from the ground up. When a web page loads in your browser, what's actually arriving on your screen? The answer is that the browser receives content in a specific format, and that format is HTML. HTML is what the browser reads and uses to display the page to you. So every web page you've ever seen starts with HTML being sent from a server to your browser. But here's the important thing. HTML doesn't come alone. Alongside HTML, there's almost always CSS as well. These two technologies travel together to your browser, and together they make up what you see on screen. Understanding both of them is essential to understanding how the web works. So what exactly is the difference between HTML and CSS? Think of it this way. They each have a completely different job. HTML is responsible for the structure of the page. CSS is responsible for the design and visual appearance. They are not the same thing, and they are not interchangeable. Each one handles a distinct part of building a web page. HTML's job is to define the structure of a web page. Think of it like the skeleton or the blueprint of a building. It answers questions like, what content goes on this page? Is there a heading, a paragraph, an image, a list? And how are these pieces arranged relative to each other? What's grouped together? What's separate? All of that structural information lives in the HTML. Every section you see here, the header, the navigation, the content area, the footer, all of that is defined by HTML. HTML tells the browser, here's a heading, here's a paragraph, here's where an image goes. It's purely about what exists on the page and how it's organized, not what it looks like. Once HTML has laid out the structure, CSS comes in and handles everything visual. Want to change the color of a heading? That's CSS. Want to make text bigger or smaller? CSS. Want to position one element next to another or stack them vertically? CSS handles all of that. CSS is the design layer. It takes the raw structure from HTML and makes it look like an actual polished web page. So color, typography, sizing, spacing, positioning, every visual decision you make about a web page is expressed through CSS. This is a really important distinction to internalize early on. When something looks wrong, you check CSS. When something is missing or in the wrong place structurally, you check HTML. The instructor makes a deliberate choice here about the order of learning. Today, the focus is entirely on HTML, understanding its structure, how it works, and what it can do. CSS comes later. This is a smart approach because if you try to learn both at the same time before you understand either, it gets confusing fast. Master the structure first, then layer on the design. Rather than jumping straight into building a full web page, which can feel overwhelming, the instructor starts with something much more manageable, a single card component. A card is a small, self-contained piece of UI that has an image, some text, and maybe a button. It's a perfect starting point because it contains all the key HTML concepts you need in a compact and understandable form. Each part of this card maps directly to an HTML element. The image at the top uses an image tag. The title uses a heading tag. The description text uses a paragraph tag. The button uses a button tag. This is exactly how HTML works. Every piece of content on a page corresponds to a specific HTML tag, and learning those tags is how you learn HTML. This is actually a really important pedagogical point. When you're learning, the goal isn't to build everything at once, it's to understand one thing deeply. A full web page has dozens of moving parts. A card component has just a few. By starting with the card, you get to focus on the core ideas of HTML without getting lost in complexity. Once you understand the card, scaling up to a full page is much easier. When working with images in HTML, one of the most common early frustrations is images not loading correctly. During the session, the instructor and students run into exactly this. Some images display fine, while others show a broken image icon. Understanding why this happens is actually a valuable part of learning HTML because it teaches you about how browsers fetch and display resources. In HTML, images can come from three main sources. First, an external URL, a link to an image hosted somewhere on the internet, like a Facebook or Google image. Second, a file on your local computer. Third, an image hosted on your own server. Each of these has different behavior, and that's exactly why some images were loading and others weren't during the session. Here's the key insight. An external URL works for everyone, as long as the image is publicly accessible on the internet. Any browser can load it. A local file only works on your own machine. Nobody else can access files sitting on your hard drive. And server-hosted images need to be explicitly set to public, and sometimes there's a delay before they're accessible everywhere. This is a really common point of confusion for beginners. When you reference a local image file, one sitting in a folder on your own computer, it works perfectly in your browser. But the moment someone else opens the same HTML code, their browser tries to find that file on their computer, not yours. Since the file doesn't exist on their machine, the image breaks. This is why local paths are only useful for your own testing. The practical takeaway from all the image loading trouble is straightforward. When you're learning and sharing code with others, use external image URLs from the internet, something from Google Images, Unsplash, or any publicly accessible source. This guarantees that the image will load for anyone who opens your HTML file, regardless of what computer they're on or what files they have locally. A couple of other technical factors came up during the session. One is file format. In some environments, certain image formats like PNG might not be read correctly, while others like JPEG work fine. The other factor is caching. When a server is newly set up or recently changed, it can take some time before images are accessible everywhere. These aren't bugs in your code, they're environment issues, and knowing that distinction saves a lot of frustration. Continuing from where we left off, now we're going to dig into how to actually structure an HTML card using nested divs and spans. The key idea here is learning to look at any design and figure out which elements need to be grouped together and which ones stand alone. This is the foundation of everything, before CSS even enters the picture. Before writing a single line of HTML, the first step is to look at the design and drop boxes around every section. You can see here, there's one big outer box for the whole card, then two inner boxes, one for the top section and one for the bottom. This mental model of boxes is exactly how HTML structure works. The outermost box becomes your parent div. Everything else lives inside it. Then the two inner regions each become their own child divs. This is the nesting pattern you'll use over and over, a parent div with two child divs inside it. So what's the difference between a div and a span? A div is a block-level element. Think of it as a box or container that groups multiple elements together. A span, on the other hand, is an inline element, used to wrap plain text content. If you have normal text that doesn't need a heading or a paragraph tag, a span is the right choice. Here's the practical rule. If you see multiple tags sitting side by side on the same line in your design, wrap them in a div. If it's just a piece of normal text, not a heading, not a paragraph, use a span. These two rules cover the vast majority of cases you'll encounter. This is probably the most important rule in this entire lesson. If you have multiple HTML tags sitting on the same line in your design, side by side, those tags must be wrapped in a parent div. A single tag on its own line doesn't need a wrapper, but the moment you have two or more sitting together, they get a box. Think of it this way. If those tags are siblings sitting next to each other, they need a parent. Without the parent div, applying CSS to them individually later becomes a nightmare. With a parent, you can style all of them at once just by targeting the parent. Let's build the top section of the card. Inside the first child div, we have an image and two spans. The image tag uses the src attribute to hold the image URL. You get this by right-clicking an image and choosing Copy Image Address. The two spans hold short text labels. Since they're normal text with no special semantic role, span is the right tag. The alt attribute on the image tag holds a text description of the image. It doesn't show up visually on the page, but it matters a lot for SEO. Search engines read it to understand what the image is about. For now, get into the habit of always filling it in, even with a short description. Now for the bottom section. This one is more complex because it has multiple levels of nesting. There's a title, which uses a heading tag, H5 in this case, a paragraph, and then a row of 3 items side by side. Because those 3 items are on the same line in the design, they need their own inner parent div with 3 spans inside. Notice that the heading priority matters when building a full web page. H1 is highest priority, H2 next, and so on. But when you're just building a card component in isolation, you can use whichever level feels appropriate. The instructor uses H5 here to keep the card title at a lower priority level relative to the rest of the page. Here's one of the most common beginner mistakes: accidentally writing a child div outside the closing tag of its parent. It looks almost right, but the structure is completely broken. The fix is simple. Always double-check that your closing tags are in the right place. Read your code line by line and use the formatter, Ctrl-Shift-F, to keep indentation clean. The formatter is your best friend here. When your code is properly indented, these mistakes jump out at you immediately. If something looks off visually in the indentation, that's usually a sign that a CAG is in the wrong place. Use Ctrl-Shift-F in VS Code to auto-format and catch these issues early. You might wonder, why bother wrapping things in a parent div if they seem to work without one? The answer is CSS. When multiple elements share a parent, you can apply one CSS rule to the parent and it cascades down to all the children automatically. Without the parent, you'd have to style each element individually, which is tedious and hard to maintain. When an element in your design is clickable and takes the user to another page or URL, you use the anchor tag, the A tag, instead of a span. The href attribute holds the destination URL. It doesn't matter how the element looks visually, whether it's a button or plain text, if clicking it navigates somewhere, it gets an anchor tag. There's an important distinction between internal and external links. If the link goes to another page within your own website, no extra attributes are needed. But if the link takes the user to a completely different website, you should add target = blank. This opens the link in a new tab, so your user doesn't lose your page. Think about it from the user's perspective. Someone lands on your website, clicks a link to an external resource, and suddenly your website is gone, replaced by YouTube or some other site. They might never come back. By adding target = blank, the external link opens in a new tab, and your website stays open in the original tab. This is a small detail, but it matters a lot for user experience and keeping visitors on your site. For links within your own project, like a homepage to an about page, you don't need target blank. But for anything pointing outside your domain, always add it. It's a professional habit worth building from day one. Now, let's talk about icons. Font Awesome is one of the most popular icon libraries for web development. You go to fontawesome.com, search for the icon you need, click on it, and copy the code it gives you. That code is an I tag with a class attribute. The class name tells Font Awesome which icon to display. When you paste that icon code into your HTML, you'll notice the icon doesn't show up yet. That's because the class names are defined in Font Awesome's style sheet, and you haven't linked that style sheet to your page yet. The code is there, but it's referencing something that hasn't been loaded. To make Font Awesome icons actually appear, you need to link its style sheet to your page. Go to cdnjs.com, search for Font Awesome, find the result, and click Copy Link Tag. This gives you a link element that you paste into the head section of your HTML. Once that link is in place, all Font Awesome icons on that page will render correctly. Here's an important principle. The head section is for things that are processed internally, style sheets, metadata, external library links. The body is for content that users actually see. Font Awesome's link tag goes in the head because it's a resource the browser needs to load, not something the user reads directly. One important thing to understand about CDN links, they are page-specific. If you add the Font Awesome CDN link to your homepage, icons will work on the homepage. But if you have an About page and you want icons there too, you need to add the same CDN link to that page's head section as well. The link doesn't carry over automatically. The good news is that one CDN link per page covers every single Font Awesome icon on that page. You don't need a separate link for each icon. Just one link in the head, and you have access to all the free icons in the library. It's only when you move to a different HTML file that you need to add it again. There is one downside to using a CDN link. If that external server goes down, your icons disappear. Your HTML and CSS are fine, but the icon definitions are hosted elsewhere. The solution to this is downloading Font Awesome locally and serving it from your own project. That way, no external dependency. The instructor mentions this will be covered later. For now, the CDN approach is fine to get started. Here's the complete picture of what we've built. The entire card sits inside one parent div. That parent has two child divs, one for the top section with the image and text labels, and one for the bottom section with the heading, paragraph, grouped text spans, and anchor tag buttons. Every element has a reason for being where it is, based on the design. Notice the pattern. Divs are containers, spans wrap text, semantic tags like headings and paragraphs carry meaning, and anchor tags handle navigation. This isn't arbitrary. Each tag choice is driven by what that element does. Structure first, then CSS styling later. Once the structure is solid, applying CSS becomes straightforward. Switching gears briefly, there was a question about a VS Code installation issue where one student's installer was showing only 3 options instead of the expected 4. The cause turned out to be a version mismatch. different versions of the VS Code installer can present slightly different setup screens. The fix is to download the exact same installer version being used in the lesson. If you ever run into this, don't try to reinstall randomly. First, compare your version number with the one the instructor is using. Even a small version difference, like 1.03 versus 1.09, can change what options appear during setup. The instructor shared the correct installer file directly, which is the cleanest solution when version mismatches cause problems. Picking up right where we left off, we've now covered block level and inline elements in HTML. The next major concept on the horizon is semantic tags, specifically sectioning elements. These are tags that don't just define how content looks, but actually communicate what that content means to the browser and to developers reading the code. The key distinction here is between non-semantic tags like div and span, which tell the browser nothing about what's inside them, versus semantic tags like header, nav, section, article, and footer, which carry meaning. When you use a header tag, anyone reading your code immediately knows that region is the top section of the page. Semantic tags matter for several important reasons. First, they make your HTML structure readable and self-documenting. Another developer can look at your code and instantly understand the page layout. Second, they help screen readers and assistive technologies navigate the page correctly for users with disabilities. And third, search engines use semantic structure to better understand and rank your content. So the three big wins from semantic HTML are readability for developers, accessibility for users with assistive devices, and better SEO, because search engines can understand which parts of your page are navigation, which are main content, and which are supplementary. These aren't just nice-to-haves. They're considered best practice in professional web development. An important point being made here is about learning sequence. Right now, the focus is purely on HTML structure, getting the skeleton of the page right. Once that foundation is solid, the class moves on to CSS, which is where all the visual design, colors, layouts, and spacing come in. Trying to worry about design before the structure is complete is putting the cart before the horse. This is a really common pitfall for beginners. They get distracted by how things look in the browser output before the HTML is even properly structured. The advice here is clear. Don't focus on the visual output yet. Ignore the design for now. Get your HTML right, understand your semantic tags and structure, and CSS will make everything look great once you get there. Now, let's talk about a very practical debugging scenario that came up. A student was getting an error because an image wasn't displaying. The root cause turned out to be an incorrect image link. When you reference an image in HTML using the img tag, the src attribute must point to the exact file, including its full file name and extension. Image files come in several formats: PNG, JPG, GIF, WebP, and others, and each has its own file extension. When you save an image to your computer and link to it in your HTML, you must include that extension at the end of the file name. So it's not just photo, it has to be photo.png or photo.jpg, depending on what format the file actually is. Missing this extension is one of the most common beginner mistakes. Here's a quick reference for the most common image extensions you'll encounter in web development. PNG is great for images that need transparency. JPEG is ideal for photographs because it compresses well. GIF supports simple animations. WebP is a modern format with excellent compression. And SVG is a vector format, perfect for icons and logos. Knowing which format your image is saved in tells you exactly what extension to use in your src attribute. Another practical workflow covered here is how to share your screen during a live coding session, which is essential when you need an instructor or peer to review your code. The process involves opening the screen share option, selecting entire screen rather than a specific window, clicking on your screen thumbnail to select it, and then hitting the Share Now button, which only becomes active once a screen is selected. Breaking it down step by step. First, click the Share Screen button in your conferencing tool. Second, navigate to the Entire Screen tab, not Window or Tab. Third, click on the screen thumbnail that appears, which selects it. And fourth, the Share Now button will become enabled and clickable. Many students get stuck because they skip step 3. The Share Now button stays grayed out until you actually select a screen. One more important workflow tip that came up is enabling autosave in VS Code. By default, VS Code does not automatically save your files. You have to manually press Ctrl+S or Command+S. If you forget to save and then open your file in a browser, you'll be looking at an outdated version of your code, which can cause a lot of confusion when debugging. To enable autosave, simply click on File in the top menu bar of VS Code and then click Autosave. Once it's checked, every change you make is saved immediately without any manual action. This is especially helpful for beginners who are still building the habit of saving frequently. It means your browser preview will always reflect your latest code changes. When working on an HTML project, it's important to open the entire project folder in VS Code, rather than just a single file. The recommended way to do this is to right-click on the project folder in your File Explorer and choose Open with Code. This loads the full folder structure into VS Code's sidebar, making it easy to navigate between your HTML, CSS, image, and other files. The reason this matters is that once you start linking files together, like referencing an image stored in a subfolder, or linking a CSS style sheet, VS Code needs to know the context of your full project. If you just open a single HTML file, the editor doesn't know about the other files around it. Opening the folder gives you the full picture and makes relative file paths work correctly. Picking up from where we left off, let's talk about how to open a project in VS Code. The process is straightforward. Navigate to your project folder in File Explorer, right-click inside that folder, and you'll see the option Open with Code. Clicking that will launch VS Code with your entire project loaded and ready to work with. This Open with Code option is the key step. Once you click it, VS Code opens up with your project's folder structure visible in the sidebar, giving you access to all your files in one place. One important setting that the instructor pointed out is autosave. In VS Code, you can enable autosave by going to the File menu and checking the autosave option. When it's turned on, every change you type is automatically saved. You don't have to press Ctrl+S every single time. Here's how you know whether your file is saved or not. See that small circle or dot next to the file name in the tab? That dot means the file has unsaved changes. Once you save, either manually with Ctrl+S or automatically, that dot disappears. If you see the dot, your work is not saved yet. The instructor noticed that several students had submitted screenshots where their files were not saved. Enabling autosave prevents that problem entirely. It's a simple one-click setting that saves you a lot of trouble, especially when you're just starting out and focused on writing code rather than managing files. Now, writing code is only one part of building a web page. You also need to see what that code actually looks like in a browser. That's where the Live Server extension comes in. You can find it by opening the Extensions panel in VS Code and searching for Live Server. Install it, and it becomes a permanent tool in your editor. Once Live Server is installed, a Go Live button appears in the bottom status bar of VS Code. Clicking it launches your HTML file in the browser and provides a live link. Anytime you save a change to your code, the browser automatically refreshes, so you can see your updates in real time without manually reloading the page. The instructor explained this relationship clearly. Every web page has two sides. On one side, you have the code, the HTML you write inside VS Code. On the other side, you have the output, what the browser actually displays. Live Server acts as the bridge between the two. It takes your code, serves it locally, and gives you a link to view the result in your browser. Think of it this way. VS Code is where you write and edit. The browser is where you see the result, and Live Server is what connects them. Without Live Server, you'd have to manually open your HTML file in the browser every time you make a change, which is slow and inefficient. The instructor also gave a quick recap of the bigger picture. Any web page that loads in your browser is built using HTML. HTML provides the structure and content of the page, the text, images, links, and layout. But HTML doesn't come alone. CSS, which stands for Cascading Style Sheets, comes alongside it to handle the visual styling, colors, fonts, spacing, and design. So HTML gives you the bones of the page, the structure. CSS gives it the skin, the appearance. Together, they produce everything you see when a web page loads. The class has started with HTML first, and CSS will be introduced as the course progresses. During the session, a version compatibility issue came up. One student had VS Code version 1.109 installed, while another had 1.103. The instructor noted that while the version difference, being within the same minor range, shouldn't cause major problems, sometimes a very new version may behave slightly differently or not support a feature the same way older versions do. The specific issue was that one student's newer version of VS Code wasn't showing the Open with Code right-click option in File Explorer. The instructor's solution was to share an older installer version via WhatsApp. After installing that version, the option appeared correctly. So if you ever face this issue, using a slightly older stable version is a valid fix. The instructor wrapped up the review by announcing what's ahead. Beyond the basic tags covered so far, the next step is learning structural HTML tags, the tags that define the overall layout and organization of a web page. These include elements like header, main, footer, and more, which give your page a meaningful, well-organized skeleton. Structural tags are important because they don't just display content, they communicate the purpose of each section to the browser and to search engines. A header tag tells the browser this is the top section of the page. A footer tag marks the bottom. Using these correctly is a foundational skill in building real web pages. Continuing from where we left off, when building a web page, the approach isn't to jump straight into coding the entire page. Instead, you start with a small, manageable piece. In this case, the instructor starts with a single card component. The idea is to learn how to read and reconstruct the structure of that card before touching any code. This is a really important mindset shift for beginners. Rather than feeling overwhelmed by the whole page, you zoom in on one component, like this card, and you ask yourself, what is this made of? What are the pieces inside it? Before writing a single line of code, the instructor physically draws boxes around the card to understand its structure. The card is clearly divided into two parts. The top section holds the image and stretches edge to edge with no surrounding gap. The bottom section has some padding around it and holds the text content. Notice this key detail about the top section. The image has no padding or margin around it. It goes all the way to the edges of the card. This is a structural clue that tells you the image is placed directly inside a container without any spacing applied. The bottom section, on the other hand, has visible spacing around its content. This tells you that padding is being applied to the container holding the text. Noticing these differences visually, before coding, is exactly how experienced developers read UI designs. Now let's zoom into the top section. Inside this one container, there are three distinct elements. First, there's an image, the thumbnail that spans the full width. Below the image, on the left side, there's a small text label, something like 3 days. And on the right side, there's a star rating or icon row. That's it. 3 things in the top section. 1, 2, 3. Image, left label, right icon row. When you can count the elements in a section like this, you've already done the hardest part of planning your HTML. Each of these 3 items will become an HTML element inside the top container. Moving to the bottom section, this is where most of the text content lives. There's a title, bold and prominent. Below it is a short paragraph of description text. And then there are additional rows of content, like curriculum details or metadata. Each of these is a separate element nested inside the bottom container. Even before you open a code editor, you can start guessing which HTML tags belong where. The title is probably a heading tag like H2 or H3. The description is a paragraph tag. The additional rows could be list items or more divs. This mental mapping is exactly the skill you're building. Now, here's the key structural insight. Every box you draw around a section of the design corresponds to a div tag in your HTML. The outermost box, the entire card, is one div. Inside it, the top section is another div, and the bottom section is yet another div. This is the nesting structure that your HTML will follow. Think of it like Russian nesting dolls. The outermost div wraps everything. Inside that, you have 2 children, the top div and the bottom div. Each child div holds its own content. This 3-level nesting is the skeleton of your card's HTML structure. This is the bridge between visual thinking and actual coding. On the left, you have the sketch, the boxes you drew. On the right, you have the HTML that mirrors it exactly. The outer div is the card wrapper. The first child div holds the top section content, the image and icons. The second child div holds the bottom section, the title, paragraph, and extra rows. See how directly the sketch maps to the code? The outermost drawn rectangle becomes the outermost div. This one-to-one relationship between your drawing and your HTML is exactly why sketching first is so powerful, especially when you're just starting out. The instructor's advice is clear. In the beginning, don't rush straight to the keyboard. First, take the design and draw boxes around every section. Identify the nesting. Label what goes where. Once that mental model is solid, then you open your editor and translate it into code. With enough practice, this process becomes automatic. Over time, you won't need to physically sketch anymore. You'll look at a design and immediately see the div structure in your head. But that automatic recognition only comes from deliberate practice, doing this exercise over and over with different components and layouts. Here's a small but practical observation the instructor makes. When you try to copy text from inside a card component on a website, you might notice the cursor changes to a pointer, the hand icon. That means the card has been styled to block normal text selection. You can't just drag to highlight and copy. The workaround is simple. Move your mouse outside the card area first, then click and drag your selection back into the card content. This lets you bypass the pointer cursor restriction and copy the text normally. It's a small trick, but useful when you're trying to reference content from live websites. Now, let's wrap up this session by talking about some practical VS Code shortcuts and tips that will make your development workflow much smoother. These are small things, but they add up to a big difference in how comfortable you work inside the editor every day. One thing worth clarifying, Alt+Z in VS Code is for toggling word wrap, which makes the screen look a certain way. But if you actually want to zoom in or zoom out on the editor itself, you use Ctrl++ to zoom in and Ctrl+- to zoom out. These are two different things, and it's easy to mix them up at first. So remember, Ctrl+ zooms in, making everything bigger, and Ctrl- zooms out. Alt-Z, on the other hand, just wraps long lines of text so they fit on screen. It doesn't actually change the zoom level at all. A student asked a great question. How do you trigger suggested words or autocomplete in VS Code? The answer is Ctrl+space. When you press that combination, VS Code opens up its suggestion panel, showing you available options for whatever you're typing. This is the built-in IntelliSense feature. Now, you might notice that sometimes suggestions appear even without pressing anything. That's because modern VS Code versions and AI-powered extensions like GitHub Copilot have been integrated directly into the editor. If you see date completions or smart predictions appearing on their own, that's AI at work. We'll cover those tools in a later session. For now, just know that Ctrl+space is your manual trigger for suggestions. Something important was emphasized here about the learning approach for this course. It's completely normal if things don't click the first time. Watching the video 2 or 3 times and giving yourself enough time to practice is genuinely necessary, not a sign that you're struggling. The goal right now is to pick up a light experience and then gradually build on it yourself. To close out today's session, here's a quick look at where we're headed. Today covered card structures, and quite a few tasks have been assigned. Make sure you spend time practicing those. In the next class, the focus will shift to sections, semantic tags, and the difference between block level and inline elements, all still within HTML. After that, we'll start moving into CSS. Specifically, the next class will cover semantic tags. These are HTML tags that carry meaning, like header, footer, section, and article. We'll also look at the distinction between block elements, which take up the full width of a line, and inline elements, which only take up as much space as their content. These are foundational concepts before jumping into CSS. Before the next class, make sure you're working through the tasks that were assigned. Practice building card structures, get comfortable with the VS Code shortcuts, and if anything is unclear, don't hesitate to ask. The whole point of this format is that questions are always welcome. Coming into the next class with hands-on practice behind you will make the new material much easier to absorb. Continuing from where we left off, let's now look at one of the most common problems beginners run into when working with HTML, image link issues. When your image doesn't show up in the browser, it almost always comes down to something wrong with the file path or the link you've provided in your image tag. The src attribute inside your image tag is where you put the link or file path to your image. If anything is wrong here, a typo, a wrong path, or the wrong kind of link, your image simply won't load. That broken image icon is the browser's way of telling you it couldn't find what you pointed it to. A valid image link must point directly to an image file, not a web page. Image files end with extensions like .png, .jpg, .jpeg, .gif, or .webp. If your link ends in .html or has no extension at all, it is not an image link. It's a page link, and the browser cannot display it as an image. The file extension at the very end of the URL is the key indicator. Without it, or with the wrong one, the browser has no way of knowing it's dealing with an image. This is exactly why the error message says extension missing. The link you pasted doesn't end with a recognized image format. Here's the exact mistake that was made. When you right-click on an image in a browser, you get several options. Copy link address copies the link to the page that contains the image, not the image itself. Copy image address copies the direct URL of the image file. You must always use copy image address to get a link that ends in a proper image extension. So when you're sourcing an image from the web, right-click directly on the image and look specifically for copy image address, not copy link address, not open link. The image address will end in a file extension like .png or .jpg, confirming it points straight to the image file. The session also touched on navigating the code editor itself. At the top, there's a file menu, and just beneath it, an autosave option. When working in an online IDE, it's important to know where these controls are. Autosave ensures your changes are preserved without you having to manually save every time you edit. Keep autosave turned on while you're learning. It prevents the frustrating situation where you make changes, test them in the browser, and then realize nothing updated because you forgot to save. It's a small setting that saves a lot of headaches. Once you have the correct image address, you need to place it properly inside the img tag. The link goes inside the src attribute, wrapped in double quotation marks. This is a critical detail. If the double quotes get accidentally deleted or corrupted, the browser won't be able to read the attribute correctly, and your image will break. Double quotation marks must appear on both sides of the link, one opening quote right after the equal sign, and one closing quote at the end of the URL, before the next attribute or the closing bracket. If either one is missing, your HTML is malformed and the image won't render. The alt attribute, short for alternative text, is what the browser displays when an image fails to load. It also helps screen readers describe the image to visually impaired users. During the session, the student was reminded to write something meaningful inside the alt attribute rather than leaving it empty. Even a simple description like company logo makes a big difference. One issue that came up during the session was that while trying to fix the image link, some of the other HTML tags in the body section got accidentally deleted. This is a very common problem when you're editing code manually, especially when copying and pasting. Always double-check that your opening and closing tags are still intact after making edits. The fix is to use undo, Ctrl-Z on Windows, to step back through your changes and restore what was accidentally removed. Then carefully re-add only the specific change you intended. It's always safer to make small, targeted edits rather than large copy-paste operations that can disrupt the surrounding code. Ctrl-Z is your best friend when something goes wrong in a code editor. Each press of Ctrl-Z undoes one action, stepping back through your edit history. If you accidentally deleted several lines of code, pressing it multiple times will restore them one by one. Get into the habit of using it immediately when you notice something broke. After making all the corrections, getting the right image address, placing it in double quotes, restoring any deleted tags, and adding alt text, the final step is to test everything using LiveServer. LiveServer launches your HTML file in the browser in real time, so you can immediately see whether your image loads correctly or if there's still something to fix. When the image finally appears in the browser, you can confirm it's working by checking that the image URL in the source ends with a valid extension, like .png. In the session, once the correct image address was used and the tags were restored, the image rendered as expected, showing that the entire process of diagnosis and correction had worked. Now, let's talk about image accessibility, specifically the alt attribute in HTML. When you place an image on a web page, screen readers and other assistive technologies rely entirely on the alt text to describe that image to users who can't see it. If you leave it empty or skip it altogether, you're essentially making that content invisible to a portion of your audience. Here's the key point. Even if you think the image is decorative, like a logo, you should still consider whether it carries meaning. A logo, for example, represents a brand. Leaving its alt text blank means a screen reader user has no idea what organization or product that image represents. There is one exception: purely decorative images. If an image adds no informational value and is only there for visual styling, you can use an empty alt attribute, written as alt with empty quotes. This signals to assistive technologies that the image should be skipped entirely. But a logo, an icon, a chart, those all carry meaning and need descriptive alt text. When you're building and testing your page, using a live server extension, like the one available in VS Code, lets you instantly preview your changes in the browser. This is crucial when working with images, because you need to see whether your image is actually loading correctly before you worry about alt text or accessibility attributes. Once Live Server is running, any change you save in your code editor is immediately reflected in the browser. This tight feedback loop is what makes it so useful for debugging image loading issues in real time. A very practical debugging technique is to right-click on an image in the browser and select Open Image in New tab. This lets you verify whether the image file itself is accessible at the URL you've specified. If the image opens correctly in its own tab, you know the file path or URL is valid. The problem, if any, lies elsewhere in your code. If the image loads fine in the new tab, that confirms the source URL is correct. But if you get a broken image or a 404 error, that tells you immediately that your file path is wrong or the image isn't publicly accessible, a very common issue when working with external image URLs. When an image doesn't load, there are a few common culprits. First, the file path or URL might be incorrect. Second, the image might not be publicly accessible, for example, if it's hosted on a private server or behind authentication. Third, there could be a browser caching issue, where the browser is serving an old, broken version of the page. Each of these has a different fix. A wrong path needs to be corrected in your HTML, a private image needs its access permissions updated, and a cache issue can usually be resolved by doing a hard refresh, holding Shift while clicking the refresh button, or by clearing the browser cache entirely. One specific scenario worth highlighting is using image URLs from social media platforms like Facebook. These platforms often restrict direct image linking, meaning an image URL that works when you first copy it may stop working later or may not load at all when embedded in an external web page. This is a known limitation and not a bug in your own code. Social media platforms use a technique called hot link protection, which blocks their image files from being loaded by external websites. The safer and more reliable approach is to host your images on your own server or use a dedicated image hosting service or content delivery network. That way, you control access and can guarantee the image will always load. To wrap up this section, image accessibility isn't just a best practice. It's a fundamental part of building inclusive web experiences. Always write meaningful alt text for images that carry information. Use your browser's built-in tools to debug loading issues. And when it comes to image sources, prefer self-hosted or CDN-hosted URLs over social media links, which can be unreliable. These small habits make a big difference in the quality and accessibility of your web projects.